Hi students, in this video we are going to look at similarity. So the learning goals for this video. So after watching this video you should be able to define similar shapes and also use similarity to calculate scale factors, unknown angles and lengths. Alright, so let's start off with the definition. So two objects are similar when they have exactly the same shape and different sizes. Right? So same shape, different sizes. In order for two triangles to be congruent, that means that their corresponding angles must be equal in size. That gives us the same shape. If all the angles are the same size, or the corresponding angles are the same size, then the shapes will be the same. Now this is what makes it different to congruence. The ratio of corresponding sides must be the same for it to be similar. And that just means that if the shape has gotten twice as large, it's keeping the same shape, but the ratio between the sides is different. The ratio between the corresponding sides is different. One shape being twice the size of the other, the sides are twice as big than the other. If triangles ABC and triangle XYZ are similar, then we write it with that squiggly line for similarity. Sometimes you might also see three vertical lines for similarity, remembering it's three horizontal lines for congruency, three vertical ones for similarity. If you want to avoid confusion, just use the little tilde, the squiggly line instead. Alright, so what we're going to do is now use similarity to help do some calculations. The key step is remembering that for similarity, our ratio of sides is always going to be the same. So we've got two similar shapes here. They even look similar, just different sizes. Let's write a similarity statement for these shapes. Well, let's just use letters for the time being. So we've got a quadrilateral, ABCD, and that is similar to, and looking how the sides match up, it looks as though A and E match up, they correspond, then B and F, C and G, and then D and H. So making sure that our points, our vertices, correspond to each other in writing that out is really important. So there's our similarity statement. Now we've got to complete the following fractions, so remembering that our ratio of corresponding sides is the same. So complete the following. EF. Now the corresponding side to EF, well, we said E corresponded to A up in our similarity statement, so we can write A instead of E, and F corresponds to B. So EF going up this way corresponds to AB going up this way, and that looks like it makes sense. And then for HG, we're going upwards again. So our corresponding side will be on this other side. It should be DC. And that makes sense. Looking at H up here, that corresponds to D, and then G corresponds to C. So that answer makes sense there. Now the scale factor. We need to find two sides, work out a ratio, and then that will give us a scale factor. So we were looking for two sides here that we know. Looking at our diagram, we actually know both AB and EF, so that makes sense to use that one there. So our scale factor will be EF over AB, and we have values for those. So EF is 4.5 over 3, which equals 1.5. So this red shape is 1.5 times bigger than our blue shape. Now we have to calculate the value for x. So let's write our fraction first. So x is in our biggest shape, so we'll put that on top. X over, now the corresponding size is 4.2. And then that is going to equal our scale factor. So rearranging that, we'll take 1.2 to the other side. X equals 1.5 times 4.2, which equals 6.1 centimeters. And there's our value for x. Now finally, calculate the value of y. So here, once again, we've got y down here. Y is AD. And so that corresponding side is going to be EF. So we can say our scale factor which is 1.5, is going to equal, this time it'll be 2.4 over y. And then just rearranging that, y goes to the other side. 1.5y equals 2.4. And then this time, to get y on its own, we'll divide both sides by 1.5. So y equals 2.4 over 1.5, which equals 1.6 centimeters. And so students, that's how we use our scale factor to calculate unknown sides. If we had to work out an angle, so let's say this angle in here was 135 degrees, and we had to work out what this angle here was. Because those angles correspond and because our shapes are similar, corresponding angles must be the same size. So if this angle at B is 130, the angle at F must also be 135 as well. Sorry, that's 135 and 135 at F. They're the same size because they're corresponding and our shapes are exactly the same. Alright students, so just to review, after watching this video you should be able to define similar shapes and use similarity to calculate scale factors and unknown angles and unknown lengths.